floating on the open sea, provided that the water is relatively calm. Would this be, according to your experience, you have done now your project from a small scale, medium scale, you're going to megawatts now. Would you dare to say in a few years we may have floating PV systems out in the water and have a cable back on land?
On the floating on the sea, it is not easy because we have to develop a new photovoltaic module on the salt. So we have to develop new modules.
And that will eventually also increase cost, and then unfortunately the return on investment or the levelized cost of electricity then also gets lower. But it's still certainly an interesting option, especially for countries which are tight in land or need to or want to do more solar than they actually have land area. Now because the idea is to maximize space which is already in use, like landfills or like lakes. And one example which is predominantly applied in Europe, in Germany, Switzerland, is the use of highways, noise barriers. So wherever you have land which is available, which is idling, which does not generate revenue today, that can be used at any given point in time. Maybe from Cypark point of view, are you looking in other areas? Because apparently for you, a standard ground-mounted system is too boring, so to speak. Do you have other ideas where you say, wow, this could be something where we can make a difference, where we can put land to use or areas to use which are idling today, and yet create a sustainable business model on it?
I think you are right. I think the opportunities for a developer to develop a solar system is not only limited to the ground. I think for us at least, we have explored opportunities such as, for example, factories. I think in Malaysia, since the feed-in tariff scheme was developed, I think there's a lot of interest, especially on rooftop systems. I was made to know that there are several already being done, several projects, even up to a megawatt scale on the rooftop. Obviously, it has to be a very large roofs. I think for that particular project, it was a warehouse, if I'm not mistaken, warehouse or logistic facility, where it was a huge facility. Yes, I think we are exploring, but nevertheless, we would like to, for us at least, we would like to concentrate on the land bank that we have, so to speak, and we would like to pursue. But of course, we have obtained interest from, we have been asked, whether do you do solar on, say, warehouse? So the answer is yes. Number two, car parks. We have also explored on roof of stadiums even, car parks of stadium or hyper malls. This is what we are looking for. But in our context, we were very much in the past looking towards more than a megawatt scale. This is what we wanted to focus into. Not that we didn't want to go into those category of projects, but rather we want to focus on the megawatt scale for us. So, I mean, yes, the opportunity is there, assuming that later in the near future, who knows, the panels will become more efficient. So for every 60 cell, instead of 250 watt panel, it becomes 500, who knows, so then we can explore the opportunity to come back. Because our aim as a company is to become a power producer. So we have to go towards a large utility scale as opposed to the small, medium scale.
Coming back to the topic of solar thermal, what we had earlier, because then if you're talking about factories, you have again this issue of competing use, and there's a lot of factories in semiconductors or in petrochemicals where you have a need for a lot of process heat, hot water, but it's barely seen at all out here in Asia. What would it take to get more solar thermal use into the industry and into the market?
Yes, as I said, based on our survey in Taiwan, 2/3 of the energy for industries is heat, and temperatures as high as half of them. The required temperatures is up to 250 degrees of centigrade. So if the energy required is in form of the heat, then the direct utilization of solar thermal is much better than from the PV, because as far as the efficiency is concerned, solar thermal is higher than the PV. Right? And by the way, I just reflected to the previous question you mentioned. Now in Taiwan, the Taiwan government has a very ambitious plan. They try to install 1 million set of PV, okay, in the recent 20 years, within the 20 years, 1 million set. And let me tell you, so for that so huge amount of the PV, that will be counts on the roof, building of the roof. And the total number of buildings in Taiwan could be just as 2.5 million only. So 40% of buildings would be equipped with the PV. So that's based on a small system. That's the ambitions of Taiwan government.
That's a good ambition anyway. It's well, the beauty of solar is that it can be distributed and you can generate electricity where you need it right away, and you avoid this classic generation, transmission, distribution model, and basically cut out the transmission and also cut out the losses, the technical losses and the economic losses that are associated with transmission. It's a little bit, and the gentleman from was asking about this, it's a bit more tricky from a utility and from a power systems operator perspective, because it's not so known how the variability of the output eventually affects the stability of the power grid. But nevertheless, it's very advantageous. Now the question generically is, can we get to new innovations or to such new types of systems without subsidies or without help from a government? And I think Korea is one of the countries that started very early with government policies and a feed-in tariff already in 2006. Maybe you can give us a bit the view of how Korea would try to push for solar.
No company or nations can achieve viability and profitability without a subsidy to push the solar energy business, at least until the grid parity is reached. Governments around the world need to play a leading role in the development of solar energy to create new demands, expand the green energy development, and reduce greenhouse gas emissions. The Korean government had supported the solar industry through a feed-in tariff system until 2011, and it put the renewable portfolio standard system into force in 2012, and plans to develop 1 gigawatt class photovoltaic system by 2015. In case of 200 kilowatt site land-based project, the electric rate per kilowatt hour was fixed at 408 Korean won in 2011, but it fell to 370 Korean won in 2012 due to the policy shift. Nonetheless, the photovoltaic electric rate is approximately 2.5 times higher than any other electric generating rate. So we cannot guarantee a stable profit due to the sharp drops in renewable energy certificate price in spite of the increase of system marginal price. At last, it leads to a solar energy develops reluctance for other new investment except for rooftop photovoltaic. So in general, rooftop photovoltaic are more profitable than land-based photovoltaic, owing to government incentives. For this reason, the Korean government prefers developing rooftop photovoltaic systems rather than general land-based photovoltaic to prevent the possible destruction of forests or farmlands. As a result, we cannot achieve profitability with only technical innovation and cost reduction when we develop land-based photovoltaic, especially if the government continues to insist on an economic incentive policy for rooftop photovoltaic. I think the government should take action to stimulate investment in land-based photovoltaic and floating photovoltaic.
Okay, thanks for the comprehensive answer. We are close to reach grid parity anyway in many places, and what we heard earlier today in the Philippines, there are large-scale systems being traded even without a feed-in tariff. Singapore has reached grid parity, at least for larger systems. So I think it's only a transition phase which we have to bridge for the next few years, because the real sustainable business model will then work when you have no subsidies involved anymore and you have private sector initiative between companies and generation companies and end users.
First year it was 95 cents, depending on what the capacity of the installation. So there are various up to a certain kilowatt is so much. Obviously, the higher you go, the 1 megawatt is cheapest. So in our case, at that time, last year it was 95 cents. So for policy, obviously, there's a digression. I think that 3%, if I'm not mistaken. But recently, the SEDA, the Malaysia's in relation to the solar renewable energy business, they have actually reviewed the tariff. So we see that next year the feed-in tariff will go down as much as 20%, the regulation rate. So the reason why they did that is because from their research, and they believe that the cost per watt could go down. So that's the question. So people like us, we are actually well, at one hand excited, but at the same time intrigued by how come, for you to go down, the cost of per watt of panel must go down 20% for next year. So because from our experience right now, even at the large scale, we do see a reduction in terms of cost per watt, but nevertheless it is not that drastic as 20% for next year, and the following year another 20%. So we are still waiting. But nevertheless, everybody is still encouraged in Malaysia. So we believe that prices will continue to drop, especially on the module. Not so much on the balance of system, project prices are quite stabilized, but also on the module itself. So
Do you?
Yes, the last year is 95 cents, this year is 60-something cents, and it will digress further.
Do you get a premium for putting it on a landfill?
No.
Because this is the case in Germany, that they have special zones where what I mentioned earlier, like for noise barriers or even literally for landfills, that they say these are unused areas, we could leverage them for solar, but we understand that they are more expensive to be built, and in Germany at least you get a premium when you use such areas, and they basically compensate for the 10-15% more cost which you eventually incur, so that you have a level playing field with those who just put it on a regular land area.
In Malaysia, the government do give a special tariff, which is better than land. Okay, so never mind. So I think that's a very good point. I will raise to the SEDA so that they can give me a better special tariff. But anyway, for rooftop, they do give a much higher tariff. Number one, if you build it on the rooftop. Secondly, as a building material, if it's integrated in your roof, so you get a much higher tariff. So that is what they are giving right now for solar. So if you have a car park, you construct the car park using a solar panel, so you get special tariff and so on.
Other questions from the floor?
Obviously, I mean, in countries like, I think in Singapore, if I'm not wrong, if you install a solar panel, you can't sell it to the grid. So how do you encourage building owners to install? You know, I mean, obviously Taiwan seems to be able to encourage, you know, and trying to install 40% of the capacity. But you know, in other countries, how do you encourage building owners to, you know, install a solar panel and presumably, you know, at certain rate, and because it's very much dependent on the tariffs, right? The higher the tariff is, obviously, the more feasible it is to install panels, and that is very much also dependent on oil prices, and also, you know, the cost of the panels. So, how do you encourage building owners to, you know, install more panels, especially in countries where there are a lot of sunshine? You know, but there are not many building owners seems to be adopting. I mean, the adoption rate is not as high as one would expect.
We do have reached grid parity for larger system, and it's reaching grid parity for residentials as well. Grid parity means if you buy a system, install it on your house, and you calculate it for a 20 years lifetime, which is typically the case, and including all the warranties, that your rate is then below the 27 cents, which you normally pay to Singapore Power today. You may have a mismatch, though, in the generation during the day when you're at work and nobody's at home, and your load may shift in the evening. So you do have the right to feed into the grid, number one, and you can have a second meter which measures, or a bidirectional meter, which measures basically what you have generated and what you have consumed, and this will be offset against each other. So you can do a net metering in a sense. The only caveat today still is that for any export or any delta which is exported into the grid, you have today still to pay what you call a grid utilization charge. But this is in discussion whether this, at what level this has to be, and whether this is required for distributed generation in the first place. So the incentive today, since there is no feed-in tariff here, the incentive is that you buy down your electricity rate, and eventually you lock in your electricity today. So if you install a system today, and your levelized cost of electricity will be, let's call it 27 cents for it. It will be 27 cents over the next 20 years, no matter what the electricity cost eventually will be. And most probably it will not be 27 cents in 10 or 15 or 20 years from today. It will be way higher. So you lock in your electricity price today, and you also are free of any fluctuations in oil, gas prices, or inflation. It's getting now, it's really taking up. So Singapore has an installed capacity of about 10 megawatts today, and we're getting more and more inquiries that 500 kilowatts, 1 megawatt systems. We just commissioned, and we were owner's engineer for Keppel Green Trust, who built a 1 megawatt solar plant in Singapore. We're involved in another megawatt solar plant at the moment, and we're in discussion where someone wants to put a 2 or 3 megawatt plant. So it's really gaining momentum now that solar module prices have come down so dramatically over the past 3-5 years that it really that you really hit this grid parity mark to say now it really makes economic sense even without a feed-in tariff, but just consuming all the electricity on site where you have and most factories or most larger areas which are available, they have plenty of demand at the same time. So you easily can do a net metering in a sense that you don't even have a physical exporting into the grid. You just reduce your load. So from a utility perspective, you're not generating and feeding in. You're what you call a negative load. So you consume a little bit less or less than you had before. And that works quite nice now.
Per megawatt, okay, the first farm which we constructed, the 8 megawatt one you saw a photo just now, that was done way back in 2010. So at that time the prices of module was quite high. I think we were there about $2 at that time. Bear in mind, because in terms of cost, our cost in terms of construction is much higher, as I mentioned. Because we have extra in terms of the design of the structures, as you can see this now, we have footing, so those are costs which we have to put in. Not only that, the other thing which plays a crucial part is the grid connection. Some of on that side, our connection point was about 3.5, 4 kilometers away. Within the same site today, we are also building another 5 megawatts. And but the connection point is about 8 kilometers away. So that plays a lot of what do you call this part in terms of cost per watt at the end of the day. But during that time, we were about I think what 2 something, 230. I believe get the market rate then for Malaysia, for our region at least. But today we are hoping to go, I don't know, anywhere below 2, most definitely, because we've read so much in the papers, and everybody is going down in terms of module cost per watt. So for our future project, obviously we will be hoping to get the same what the other are getting. Especially from what we understand, that in the EU right now the market is somewhat there's like an excess of stock or something like that, So generally, from our experience, that we can see that if there is an excess of stock somewhere over there, we can generally get the price much cheaper. I mean, we have actually experienced it firsthand, especially when we did our first 100 kilowatt. So that one was very exceptional in terms of price. So at that time, we paid early 2010. So we got a very, very good price for that 100 kilowatt effect. And we came from a very reputable company to supply the solar energy.
But generically, we are currently in the range of $1.5 to $2 per watts capex. And then it depends on what's the quality level you're looking at. And this is like you have a solar system and you have your cable and your plug in your hand. If you have another 10 kilometers of high power line, that certainly adds to the cost. But that's pretty much the range. But you have to watch out for those who have excess inventory and sell over price, because it may not be worthwhile talking to them, because at the end of the day, you're doing a 25-year or 20 or 25-year investment, and warranty is a very crucial. And we heard Kevin talking about it earlier, that they had offers, indecent offers from Chinese and other countries' manufacturers. And at the end of the day, they together with the bank decided we go for a rock solid Japanese manufacturer. Warranty is profitable. The warranty is written, the paper it's worth on, because you run the risk if you have a tier 2, tier 3 supplier, that if your modules after 5 years start delaminating or underperforming, that they close down the factory faster than you can reach the country to complain about it. It's been a long day, so otherwise I will close the panel discussion here, and since it's 5:30, it's end of the day. And just a few words in summarizing from my side as chairman of the discussion. I think we had a very, very interesting day today. We covered a quite variety of topics. At the end of the day, you basically got the full recipe of succeeding in solar. We started out with giving the prospective markets. We had talks about Philippines, Malaysia, Thailand, Middle East was quite promising. So there are big markets out there. There's business models out there. Independent power producers become more and more prominent here in the region. Eventually, Kevin also gave an overview, a blueprint on how you properly prepare and develop a project and implement it in order to be bankable. Don't cut corners. Do a solid approach. Don't rush into projects. It's a long-term approach. You have to engage local stakeholders as much as possible, and then you will succeed over time. It's not a kick and rush, although it's tempting, and we saw markets in Germany, in Europe, like Spain, come and go. There was a big gold rush in 2008, distorting the whole PV market to some degree, even influencing or triggering the massive decay in module prices. But this was
Thank you.
not sustainable over time. So it's a long-term business. It's a power business.
Or we're just going to let someone from the other room.
We learned about
finish.
alternative technologies, solar thermal, high concentrating PV, which is very suitable, have high DNI, high direct irradiance locations, many days without clouds and high irradiance levels. Middle East, tropics, bit questionable, but at least for many other parts, or certainly parts of India, parts of China, are very suited for concentration and solar thermal applications. And eventually now we got some new ideas on out-of-the-box thinking, where can you put solar in the first place, looking at landfills, looking at floating PV. So you basically have all the tools. You heard about the recipes, how to succeed. Now go out and do it. And I always like to close with, there's the company Unicos in Germany, and they have this beautiful company motto, and it's printed on every brochure: let the fossils rest in peace.